So here we are still in 5A, page 4. We're going to continue to talk about the idea of slope, but we're going to attach it to some scenarios now. And oftentimes graphs really do tell a story, and that's kind of what we're going to do in these pages. I probably will do. Let's see, I'm looking at page 4 and 5. They go together, so this video may be a little bit longer. You're certainly welcome to pause it if you need a break. But I'll probably just do this entire video and go through both page 4 and page 5. All right, so let's remember the formula for slope. M is equal to y sub 2 minus y sub 1, or you can put y1 minus y2, but whatever you start with, whatever subscript is in the numerator has got to be the one that's in the denominator also. And we're remembering that this is rise over run. If you're looking at a graph, you have to rise up before you can run. We're also remembering that a positive slope rises from left to right, a negative slope falls from left to right, a horizontal line has a slope of 0, and a perfectly vertical line has an undefined slope. You can't calculate it because you're dividing by 0. Okay, so there's our little bitty review. We're going to look at this graph. Now they've attached actually some personality to the graph. We've got two bugs that are moving away from an elm tree and the rose bush. So if you kind of look at what they're trying to do here, they're showing you that the independent variable is time, and the distance is a function of the time that these bugs are moving away from the elm tree. So you've got centipede, I didn't make this up, and milady bug, who are moving away from the elm tree. So basically the first question is just asking you how fast they are moving. This is the slope. In this particular scenario, they're saying, what is the slope? This question. So this is slope that they're asking you to calculate. Now, for Mr. Pede, Mr. Sen, we can look at his rise over his run, or we can pick 2 points and calculate it. So it really doesn't matter if they're both starting at 0, 0, so that's a pretty good point to start with. And now I'm looking for a point that goes right through one of these perfect intervals. When you're, and I'm not sure I said this yesterday or on the other videos, but when you're calculating slope and you're looking for 2 points on a line, it doesn't matter what 2 points you pick. But obviously, if I were going to pick a point up in here, I don't know what those coordinates are. So I'm looking at this guy right here. He looks pretty good to me. He is at 1, 3, and this guy is at 0, 0. So I know that my slope is positive because he's starting low and he's going high. I know that his rise is 1, 2, 3, and his run is just 1 unit. But now, speaking of units, we are actually talking about rates here. You guys, we talked about rates in 7th grade. Rates didn't have the same units, and so the units were an important part of our problem. So the 3 represents feet, distance from the elm tree. He is rising at 3 feet to 1 minute. For every 1 minute he is on the move, his rise is 3 feet. Or if you want to take these 2 points and actually calculate the slope, your first point is 0, 0. Your second point that I picked is 1, 3. And you can plug it into the slope formula, and you will also get the slope of 3 feet to 1 minute. You could have also picked this point up here. It looks like it goes through pretty accurately. So that would be 1, 2, 3, 4, 5, 6, 2, 6. And of course, that will all reduce down to 3 feet to 1 minute. So let's look at Milady Bug. I'll call her Mel. Her rise over her run. So let's look at a point where we can figure out what she's doing. Looks like she's got a good point right there that's on an interval. So if you look at, again, her graph is positive. She's rising from left to right, so we know that her slope is going to have a positive sign. She's rising up 1 foot, don't forget your units, for every 2 minutes. So that's how fast they were moving. And if I just ask you to do a little analysis between who's the slowpoke and who's the speedy person here, you can see that Centipede is moving faster. For every 1 minute, he's going 3 feet. And for every 1 foot, it takes her a full 2 minutes. So he's going quite a bit. What is that, maybe 6 times as fast as she is? And you can tell by looking at their lines as well. This is a nice, gentle slope. This is slow slope, slow slanted slope. And this guy is rising vertically pretty steeply. So the steep slope is the faster, higher, bigger slope, 3 to 1. And the slow moving, gentle, kind of just slanted at a really, at a really slow pace is the smaller number slope. So now something else is going on with them. This is showing their progress on their trip, and we want to know if their speeds change. So in other words, did their slopes stay the same? So Mr. Centipede, we remember his slope was, let's see, 3 feet to 1 minute. Let's look at his progress here. So now he's starting this point right here, and that point right there is perfectly on the graph. So again, it's rising up 3, it's running 1. So his Sen's slope speed did not change. Let's look at Milady. Is she still just ambling along? We're starting here. This is where she is now after they've been gone for some amount of time. And that looks like a perfectly good point. She is rising up, running 2. So her slope did not change either. What did change, just in looking at the graph? Well, the slope didn't change, but where they're starting, where they are now, changed. So the distance from the tree is changed. So this is like a time-lapse thing, and they both ambled on, and they are now this distance from the tree. And now it looks like Centipede is closer to the tree for some reason. We don't know why. Okay, third graph. Now their progress looks a little bit different. Did their speeds change? So let's look at Centipede. Here's his starting point. Here's another good one that's right on an interval. So that's up 3 over 1. So it's 3 feet for 1 minute. Don't forget your units. That's the same as right here. So his Centipedes did not change. Not change. But Milady's, I can already tell you hers changed because now her slope is negative. Up here, her slope was positive. So it may be the same rise over run, but it is now negative. So Milady is now negative. And let's look and see what the numbers are for the units. So again, it's feet and minute. I'll go start right here, and then there's a good point for her also. So she rose up, which is actually now going down because it's negative. So the rise, the negative rise was 1, and the run was 2. So her relative numbers did not change, her rise over run, but now her slope is negative 1 over 2. And what else did change? Well, the lady is moving back toward the tree. So Sean, he's still moving away from the tree, distance from the tree, and Milady her distance from the tree is going down. So Sean is moving away from tree. So that didn't change, but Milady is moving toward tree. So that's kind of the story that this page tells. Let's move to the next page real quick. So now we're still talking about these two fine bugs. And they're asking us to sketch a graph. So this has no coordinates, no numbers. This is just a sketch of a graph. What would it look like if Milady was moving slowly? So there's a word, and to the tree. So if she is moving slowly to the tree, what am I thinking about that? Well, I'm thinking her distance is decreasing and her time is increasing. So if I'm going to sketch that graph, just sketch a little graph, it might look like this. She's starting somewhere away from the tree. We don't know where, but she's starting somewhere up here. Slowly, that tells us this is a slanted, easy slope, shallow slope. So here she goes. That should be a straight line. But anyway, her slope is shallow. And again, this is time, and this is distance. So she's moving toward the tree slowly, quickly to the tree. Okay, so again, her distance is decreasing, her time is increasing, but now the word quickly is telling us our slope is going to be steep. So she starts somewhere, but now she's heading almost straight down. Much more steep of a line than that one. So that's what that might look like. Now, what would it look like if she's going slowly from the tree? Okay, so again, our time is increasing, but now our distance is increasing because she's going away from the tree. So she's starting somewhere. If she starts at the tree, it would look like that. And then as time goes on, she's got a nice gentle slope going. And what if she wasn't moving at all? That's interesting. Your time is increasing, but distance is staying the same. So here's your distance. Remember, this is the distance, the y-axis. This is your time. And she's starting somewhere. We don't know where, but she isn't moving. So as the time moves, the distance, the y-coordinate stays the same. It's a perfectly horizontal line. All right, let's look at this example. Now we're talking about centipede. This is showing a couple things going on with him, and they want us to describe his movement using specific rates. So there's your slope word, your rate, your rise over run, your distance over your time. So let's look at what happens at position number 1, right here. So he starts 1 foot away from tree. 1 foot away from tree. That's what the graph tells us. That's our beginning point. And then what happens? Well, let's look at what happens from this point to this point, because this is when the graph changes. So he's got a positive slope, and it's going up, rising up 1, 2, 3, 4, running 2. So he is rising up 4 feet for every 2 minutes, which of course reduces to 2 feet per minute, per 1 minute. So that's his next rate until, of course, he stops. So the third thing that's happening in this graph, from here to here, so these are our key points so far. He doesn't move. He stops. He takes a rest. Doesn't move for how long? We're looking at the time. 1, 2, 3 units. And now finally, he's coming back down. So now he has a negative slope. He's moving towards tree, toward tree, and let's calculate the slope. So from here to, well, we can just even use the next little point right here. This is one rise and one run for each of these. So he is rising and running at a negative 1 foot per 1 minute toward tree, and then that's his rate. And then finally, this last one, how would you describe the rate of change shown in this graph? So this is a vertical line, and we know from back up here, our little, oh, that was on the other page. Vertical line has an undefined slope. So what is this actually saying with regard to centipede and milady bug? Well, it's actually saying that the time is not changing, but the distance is. And I don't see how that's possible. How could they be getting further away when the time isn't changing? So it doesn't really make any sense. So we can prove it by picking any 2 points on this line and actually calculating the slope. So that would be, what's that? 1, 2, 3, 2. So that's 3, 2, and 1, 2, 3, 3, 6. And again, x1, y1, x2, y2. Anytime you see these x's the same, and you know they're on the bottom when you're subtracting, you know you're going to have an undefined slope, because you're going to subtract 3 from 3 and get 0. But let's just go ahead and plug them in. So y2 is 6, y1 is 2, x2 is 3, x1 is also 3, and you get 4 over 0. You can't divide by 0, so the slope is undefined. So this situation makes no sense. This situation is not possible, is I think the way I put it. Okay, thanks for watching. See you soon.